Hello guys, my name is Ravindra. Uh, Now I'm going to explain about blinking LED. Sorry. So for that, briefly explain what are the components I use, what is the board I use. For that, I use it for the product family RTX 7, RTX 7 board, FPGA board. For the edge vendor. So for that, I'll open the board. I will show you how the board. Here, I use the board. Here, as you've seen that this is the board. Actually, look like RTX 7. For next, you'll see that here the LEDs are there, 16 LEDs and 16 input pins. So in this project, I'll use for the here 16 LEDs and one clock. Uh, Here I'll show you. I basically project has shown that timer 16 seconds timer as I designed that. So I will going to the code part. What I as I taken the module has inputs and outputs. Clock has an input. A 100 mega hertz clock cycle. Here is in that 100 mega cycle clock I took for the next for the coming to output as I taken as a register. Output has a 16-bit LED. So section LEDs I took for that. Next I took register parameters for that counter. I took that. Why I taken counter? A counter can to track, keep track on clock cycles. Counter can count the many clock cycles. For that, we use the counter. Next, I use on the LED index, shifting index, shifting index. Uh, as I say that uh, LEDs as the shifting one place to another, shifting that every 1 second timer. Like yeah, starting for the LED here, next first 1 second, and the next 1 second, next 1 second, next 1 second. Like that, it go for the 16 seconds like a timer, blinking LED. So next, we'll use a behavior model, rated behavior model. For here, behavior model code for the 1 second logic. I use 1 second. You can change that 1 second to 2 seconds or 3 seconds or anything. Uh, yeah, I use constant file as a input has a clock and 16 LEDs, and as you've seen that nothing as I use only clock and LEDs I use simply. Just come to the synthesis part. As I was saying that I already completed synthesis and implementation. I already completed Bitstream also. As I completed Bitstream and I was showing that for the message part, one critical warning and synthesis for synthesis part and implement part. I get three warnings. Mm, for next, I going for the utilization, post synthetic utilization after post implementing utilization. As you've seen that I understand for the graph. For I'm coming to the power, how much power total chip consumption for these logical. Here 9.92 watts and junction temperature as 73.5. Yes, as I shown previous video, my full header as I explained that here design reports as you go into reports for that log the print for the logs whatever logs and message files my in full header video and I explain for these things. So after after editing, I will go for the RTL analysis. As RTL analysis, I did RTL analysis. That I will go for the it's actually the RTL analysis looking for the device. Here the block diagram systematical view of the whatever we can this thing. Yeah, you see that. Here you've seen that inside we get local projects. These are the blocks and marks when it's running of those things, data. If choose very well, see that marks. Two input marks will get one. These are the diagram. Go and explore these things, and you will understand what I will saying that. I think you understand. For the first time, who was watching this thing will little confusing. After you done these everything systematical and implementation and RT analysis, then you go for the hardware management for the dumping the code for that. For hardware management, you just open to trigger. For that, you insert the board. After they dump the code, I will show you output. How the output. Here you see this output.
Here I'm showing my attached board and I already dumped the code. Here the I'm getting output for every 1 second. It moves one by one. LED. It's blinking like the output will go on every 16 seconds like timer. Here I finish it the timer and it will be restart as is.